Imagine a world where nothing is certain, where a particle can be in two places at once, and a cat can be both dead and alive until you look at it. This isn't science fiction. This is the foundation of our reality. For centuries, Isaac Newton's laws told us the universe was a giant, predictable clock. But at the turn of the 20th century, a group of rebels, Einstein, Bohr, and Heisenberg, uncovered a secret that suggested the world we touch and see is just a shadow of a much deeper, much stranger reality. Today, we dive into the rabbit hole. From the mystery of the double-slit experiment to the impossible connection of entanglement, this is the complete guide to quantum mechanics. Welcome to the Quantum Code. To understand the quantum world, we must first look at the atom. For a long time, we thought atoms were like mini solar systems, with electrons orbiting a nucleus like planets around the sun. It was neat, it was tidy, and it was completely wrong. In 1913, Niels Bohr realized that electrons don't just travel from one point to another, they jump. This is the quantum leap. One moment, an electron is here, and the next, it is there, without ever being in between. But it gets weirder. Werner Heisenberg, a young German physicist, discovered that you can never truly know where an electron is and how fast it's going at the same time. The more you know about one, the less you know about the other. This is the uncertainty principle. It's as if the universe is actively hiding its secrets from us. At this scale, matter isn't a solid thing. It's a cloud of possibilities. In 1801, Thomas Young performed an experiment that changed everything. It's called the double-slit experiment. Imagine firing marbles at a screen with two slits. They would form two lines, right? But when physicists fired tiny particles like electrons, something impossible happened. Instead of two lines, they formed an interference pattern, a series of many lines. This meant the electrons were acting like waves, not particles. They were going through both slits at the same time. Scientists were confused. They decided to place a detector at the slits to see which one the electron actually went through. But as soon as they started watching, the electrons went back to acting like solid marbles. They formed only two lines. The mere act of observation changed the outcome. It's as if the universe knows when we're looking at it. This leads to the most haunting question in science. Does the world exist if we aren't looking at it? To highlight the absurdity of the quantum world, physicist Erwin Schrödinger proposed a thought experiment that has become a cultural icon. Imagine a cat in a sealed box with a radioactive source and a vial of poison. If a single atom decays, the poison is released and the cat dies. According to quantum mechanics, until we open that box and look inside, the atom is in a superposition. It has both decayed and not decayed. This means, theoretically, the cat is both alive and dead at the same time. It sounds like a joke, right? Even Schrödinger meant it to show how ridiculous the theory was, but the reality is even more shocking. In the quantum realm, this superposition is real. Every quantum computer we are building today relies on this very principle. A bit in your computer is either 0 or 1, but a qubit is both. This is why the future of technology is hidden inside a box with a cat that might not even be there. But there's something even more haunting than a cat in a box. Albert Einstein, the man who revolutionized physics, spent the last years of his life trying to disprove one specific quantum idea. He called it spooky action at a distance. Imagine two particles created at the same time. They're entangled. You take one to the other side of the galaxy and leave the other here on Earth. If you change the spin of the particle here, the one across the galaxy changes its spin instantly, not at the speed of light, but instantly. This violates everything we know about space and time. It suggests that at a fundamental level, everything in the universe is connected in a way we cannot see. If the Big Bang started from a single point, does that mean every atom in your body is still entangled with the farthest stars in the cosmos? If observation creates reality, what happens to the outcomes we don't see? Some physicists believe in the many worlds interpretation. It suggests that every time a quantum decision is made, the universe splits. In one world, the cat is alive. In another, it is dead. In one world, you're watching this video. In another, you never clicked it. We are living in a vast, interconnected web of possibilities. Quantum mechanics tells us that we are not just passive observers of the universe, but active participants. The code is still being written, and we're just beginning to read the first few lines. The next time you look up at the stars, remember, you are not just looking at cold, distant lights. You are looking at a reality that responds to your very presence. The universe is not just stranger than we imagine. It is stranger than we can imagine. Thank you for exploring the quantum code with us. Stay curious, and we will see you in the next reality.